Hello and welcome everyone. Thank you for joining us today for our webinar on future-proofing digital assets, Digital Bedrock's approach using Quobyte. In today's session, we will highlight the significance of advanced storage in safeguarding digital assets and showcase a real-world application in use by Digital Bedrock, a leading provider of secure, managed digital preservation services. Our expert today is Linda Tadich. She is a founder and CEO of Digital Bedrock, a trusted, managed digital preservation service that partners with libraries, archives, museums, producers, studios, artists, and individuals to preserve their digital content. Her over 35 years experience includes positions at HBO, the Media Archives, and Peabody Awards collection at the University of Georgia, Art Store, and Pacific Film Archive. She has also taught as an adjunct professor at UCLA and NYU. Linda consults and lectures on digital asset management, audiovisual and digital preservation, metadata, and the impact of digital preservation on the environment. With that, I'll now pass it over to Linda.
Okay. Thank you, SK. Thank you. Thank you all of you for joining and spending about 20 to 30 minutes on discussing digital preservation, what Digital Bedrock does, and how we use Quobyte. So let's go on. So I'm assuming if you are watching this or participating in this, that you have digital content. So you have a digital archive that could consist of files or digital manifestations that were created by digitizing analog media, your film, your video, your audio, your still images, your documents. They were originally analog, you digitized them. So now they also exist as digital files. You also have born digital content. So the content was created as digital formats. But now just because it is digital does not mean that your content is preserved. I use this term called the silent fire because you could have data that you think is okay because it's digital. However, it could actually be at risk and you don't even know it. So for example, you can have data storage carriers. They can be obsolete, they can fail, and your data is not the data's fault. It's sitting there just minding its own business, but then it's the carrier it's sitting on that could fail, and then you lose your content. It can also be because the file backup or writing software that was used to write the data to the storage, it can be proprietary or obsolete or both. So if you have a proprietary backup writing system that wrote your data and it's also obsolete, how are you going to get that data off that storage? The storage file system on that storage carrier can also be proprietary or obsolete. And then the file formats are the codecs. So again, they're just bits. They're just sitting there minding their own business. But in order to read that data, you need to have software in order to render it. And that software can be obsolete. That software can require an operating system to run, and that operating system can be obsolete and no longer supported. And then that operating system might require hardware to render it out. And if all of those are obsolete, then your data is just stuck on the carrier. How do you get it out? And then what we see a lot of is where it's actually human or machine errors. The data wasn't written correctly. And so, for example, somebody might be writing data to a drive or to an LTO tape, and they eject it or they stop it before it has completed writing. And then the data is corrupted. It's not a complete file. We find a lot of that actually. And again, you think the data has been written to your storage media, and it actually isn't. And it's corrupted, and you have no idea, which is why I call it the silent fire. So keeping all that digital content that you have to keep it usable so you can use it in the future. Why are you keeping it? It's because you want to use it or potentially use it in the future. That's a very complex process, and you have to do it over time. You cannot just put your data somewhere, store it, and ignore it. That is not an option with digital preservation. You need to know everything about that digital object, about the files, what's the essence. You need to know all the metadata about the data. What are the technical characteristics? What is some of the embedded metadata? Files don't lie. If you can pull out the data from that file that's embedded in it, then you will know how it was created quite often. You need to then do actions over time to preserve that object. You need to run fixity checks. You need to migrate it to new storage. You might even need to migrate the actual digital file if it's an obsolete file. You have to do this work over time. It is more than just traditional IT archiving and backup, which has its purpose, but that is usually when you're just putting data somewhere and it's just archived and you think that is okay, or you're just backing it up. So digital preservation requires analysis and appraisals, a lot of work even before you get to the digital preservation stage. Do you know what is on your older storage carriers, or is it just like hard drives or LTO sitting on a shelf? Can you get the files off? How do you know how to get the data off? Are the files truly what you think they are? Are the files themselves okay? Do you have checksums for them that you can do ongoing fixity checks? A fixity check, that's digital preservation term, which means basically, let's say once a year, you're going to verify that the file's checksums are still valid, that the bits have not changed. Do you need to preserve everything? Can you perform selection and appraisal first? Because data is just so easy to create. We all know that. You just take a bunch of pictures on your phone or video, and then suddenly you have a lot of your own personal data. So just think about it with an organization. Digital creation is so easy. You just keep going and shooting, and then you realize, oh no, we have all of this. What is it? We have no idea. Do we need to keep it? Because you're paying for that storage, you're paying for that maintenance over time. Do you need to keep everything? What content then can just be stored in the cloud and then maybe worry about it later? And then what should be stored offline? Not everything has to go into the cloud. Definitely, because that is cost, that is a lot of management in the cloud. Some data, if you don't need constant access to it, basically like 80% of data in the cloud is archival, where it's not being used, but you want to keep it over time because you don't know if you want to use it in the future. You don't need to keep that online. Help contributing to destroying the environment, which is a whole other topic, which if you have questions, I can get into later on. Anyway, you can store a lot of data offline and not even in, but then you still need to manage it. So that's what we do. So Digital Bedrock is a managed OAIS compliant digital preservation service. What is OAIS? That stands for Open Archives Information System. That is an international ISO standard that digital preservation is used to make sure that we are doing the processes that are required for digital preservation. All we do is digital preservation, active managed digital preservation. We don't do digital asset management. We don't do collection management. We don't provide access. We are a dark archive, but we manage your files offline. There is no license subscription. There is no hardware you have to buy. We really become part of our clients' extended staff and infrastructure. We are their partners. And we can preserve any format, any content type. And our database that we use to do all of that preservation work, our system can support any type of data and metadata, any file type at all. So what we do is, if you have checksums, if you have those hashes, doesn't matter what kind it is, we'll verify your data upon receipt when we receive it. But what, of course, because we want to know that the data is okay when we receive it. But then what we do is we create SHA-512 checksums for ongoing annual checks. Now, SHA-512 is actually recommended by the Department of Defense to use that hash because it will be less spoofable when quantum computing comes out, when that happens. So we're already doing that from the beginning, to make sure that those SHA-512s exist for all our clients' data. We then process it through our system and we extract all that technical and embedded metadata that I referenced was in the files, because that doesn't lie, it's in the file. And all of that metadata becomes indexed, and that's very important. So then you have access to all of that unstructured metadata that was pulled out of the files in our DPA, which is our digital preservation application, but also in the client's portal. So clients can go online to their portal. They can't touch their files. Everything is stored offline, which I'll get to in a moment. But because it's stored offline, we pull out all of that data out of the files. And one file can have hundreds of bits of metadata that we can pull out from using our tools. And then the client has access to that metadata. So you can do searches yourself to find out exactly what file formats are, what camera, what lens was used to create it, who created it, what software was used, what hardware was used. All of that information can be in a file and you can search for it. Now, we retain the original directory structure that as the files were given to us. That's very important for context for us and for the client so that we can track file relationships also. We monitor for format obsolescence vulnerabilities through our digital object obsolescence database, or the DOOD. We actually have a patent for the underlying algorithm for that. We retain an audit trail of everything that we do. So again, we don't actually look at clients' files unless they ask us to, but they might sometimes ask us, hey, can you reorganize files? Can you rename them in bulk? We can do all of that work, and we have tools that can do that, and then we keep a record of this is what it was called when we received it, This is then what we renamed it according to the client's instructions. We have audit trails for everything that we do, fixity checks, everything. Once all that processing is done on our, basically the storage is on our servers is where we're doing all that processing. And I'll get to that in a moment when I describe how we're using Quobyte. We then write the files off to 3 copies of LTO, and we're using LTFS, which is the open file system. And you have to use open tools in digital preservation. You cannot lock anything into any kind of proprietary system. Once those are written and we verify those SHA-512s that everything was written okay, we then literally lock them up in 3 geographically dispersed locations around the US for disaster recovery. But once a year, we take 1 copy out, our local copy that's kept in a safe, in our bunker, as we call it, 2 levels below ground in a data center. So then we can verify that the files are still okay. And we've done like 42 million files or so at this point, and every single file has been okay because we're just so careful and thorough. Then we will migrate to future storage media in the future. Again, you can't just store things on a shelf and ignore it. You have to keep managing it over time, doing those fixity checks, migrate to future storage media. The clients don't have to worry about it. We do that for them. All of this is implemented within an open architecture. Again, it's so important that nothing is locked in any kind of proprietary system. And actually, one of our biggest selling points is we're an easy exit. If people want to leave us, it's not hard to get your data out. We will give it to you. We really work with people. There is no vendor lock-in because how we're doing everything is just so open. So who we help is pretty much anybody because everybody has digital content. So, and because our clients are so diversified in client types we work with, our system has to be open enough to support any type of client, any size collection, any type of format. So most of our clients do come from media and entertainment, where there is a big need to preserve content that they have intellectual property associated to, but make sure it's all safe and taken care of. Libraries, archives, museums, performance venues like orchestras, theatrical venues, museums, they have time-based media artworks. These are digital artworks. Just as a museum might buy paintings and sculptures, they buy digital art as well. And so we preserve the artworks that these museums purchase. We support creators, individual artists who want to make sure that their files are okay for going into the future. We're kind of like the insurance policy for individual creators and the media and entertainment in the museums. Filmmakers, composers, photographers, and public broadcasters, as well as government agencies. So again, our clients' data security is paramount. That's why we store the data offline. Nobody can touch it. Once the files are written to LTO and verified, the data is wiped from our servers. And so, as I mentioned, to date, we have processed 42 million files through our system, and every single file is fine. And that's 42 million files times 3 if we make 3 LTO copies. And some clients ask for their own copy as well. So let's get to Quobyte and how Quobyte has helped us to do all this work and to process all this data seamlessly, quickly, so that we can have more data coming through to support more clients. So yes, all of the data is written to LTO tape and it is stored offline, but it has to sit somewhere, on this temporary processing storage for us to work with it. So right now we have 1 petabyte of storage just for processing storage on 6 clustered servers. The Linux version that we're running Quobyte on is Debian 12, and we are processing between 30 to 50 files concurrently at one time. And so that means we can be verifying the checksums in the clients, we can be verifying our SHA-512s, we can be extracting that hundreds of bits of technical and embedded metadata per file, all of that happening at one time. So before Quobyte, so when we started, we were a startup. We weren't founded by a VC company. We were started by people. And so we used an open source storage platform at that time, because again, you want to start, as a startup, you start with like what you need to get going. And then we built our infrastructure so we can keep adding to our infrastructure as we go, to keep adding more tape libraries, to keep adding more service storage as we need. So at the beginning, what we had to do was we would copy and move data between different processing storage areas. It was very tedious. And then, of course, when we had to delete the files, after we do all that processing through our system, write it to LTO, we delete the files, as I mentioned. the process sometimes crashed, during this deletion process. So for example, one TV show, like if a regular TV season, watch TV, can have maybe 10 episodes in it. The digital masters for one season can be between 70 and 160 terabytes for one show. And so we usually are processing, not usually, we do, we process more than one of those at a time. So you can see that's a lot of data that we have to process through. We have to be fast and accurate. So we started using Quobyte November 2021. So it's just been like 2.5 years. So using Quobyte, the data is in one location. So here before I said we had to keep moving data between the different processing storage areas. Now the data just lives in one location. This is saving us time from having to move data around. It removes opportunities for error. Again, human error. The weak point is quite often is the human point. The human point is fabulous and wonderful, and you need humans to do digital preservation, but we are humans, and machines can make errors as well. But using Quobyte also meant we have faster file processing because it's so fast. And that's why I was speaking with our system administrator earlier this week to make sure what I was saying was correct and seeing if he had anything else to say. And he said, like, it's just so much faster. He said 50% faster, probably even more, that. And so and this includes doing all that deletion. It's just, and we need to get the data off that 1 petabyte of data so we can make room for the next client's data to come through. So it's really important to be able to have a seamless, fault-proof way to get this data in and out. And the main thing is I have here in green, happy system administrator. He says it just works. He says what we were doing before we were using Quobyte was essentially, like he said, in the Stone Age. And so he doesn't have to worry about it. He can think about other things that he has to do. It's like no babysitting. It just works. It doesn't fail. And so we're very happy with how we're using Quobyte because it can speed through our processing so that we can have more data coming in and out so we can support our clients. And so it has become a very important tool for us to use in our whole infrastructure. So I have here, here's my email address and a link to our website if you want to see more information about what we do. But also Quobyte released a very nice case study about us. And so it's on their website in case you have any, if you want to read it. Have any other questions? Okay.
Wonderful, Linda. That was very informative. Let's get to the questions. We have a handful to get through. The first one asks, beyond storage solutions, what are some of the biggest challenges you face in ensuring long-term accessibility and usability of digital assets?
Okay, well, storage obviously is critical. That's what this conversation was all about. But also, as I was alluding to, is like, how do you know what you have? Can you even get the data off whatever old storage carriers you might have your data on? Do you know what it is? And then the obsolescence factors, because digital, everybody probably watching this video or this webinar, we've all shot things or we have files we can't open right now because the software doesn't exist or it's an older version of something and you can't open it up. So those obsolescence factors are some of the really critical issues that are out there besides storage.
Thank you. The next one, in your experience, what strategies have proven most effective in combating digital obsolescence?
Okay, so you have obsolescence in many ways. So you have obsolete storage, as I was talking about. So you could have LTO2 tapes, for example. Well, LTO9 is a current generation. They definitely don't make drives anymore to be able to read that off. And so then you have to think that, all right, so I already know I have this obsolete storage medium, and then what kind of obsolete drives do I have to find on eBay or whatever, in order to get the data off? So there's obsolescence of the storage medium. There's obsolescence of the platforms and able to get that data off. Do you need to go back to a Windows NT, in order to get, or a Windows 95 system in order to get that data off, besides the drivers and trying to find the drivers and what's the software to get it off. So there's obsolescence in the storage and in the means to get it off. And then you have the obsolescence in the data itself. Now, there are different, so as far as I'm trying to identify a format in the obsolescence factors of formats, you have to go in and find out what is that format. And that can mean going into the signatures, file signatures of these files to find out exactly, into the hex, which is what you have to do to really identify what is this file and what, how is it created and what flavor file it is. So it's it's kind of complicated, but the nice thing is like there's a robust international digital preservation community where people are tackling these issues. And so developing tools to try to deal with the identification of obsolete formats. The problem with the obsolete storage medium technology is a more difficult thing to crack, actually.
Thank you. The next one asks, for organizations with limited resources, what initial steps would you recommend for
Mhm.
establishing a digital preservation program?
Right. So that's a really good question because and I as you mentioned in the intro that I taught at NYU and I taught at UCLA, and I always tell my students like, okay, you can go through everything I just described and it might seem overwhelming, all the steps you have to do, but most organizations can't do this. They can't do it on their own, which is actually why I founded Digital Bedrock, to help people, to help organizations do that work, because they don't have the means to do it themselves, or the knowledge, or the infrastructure, or whatever. That's why we exist. But you want to do it yourself, which is always the best thing to do. Start basic stuff is where like have this, stable storage, and again, you don't have to keep everything online. It's just a matter of like organization, making sure that you have unique file names and folder structures that are really clear what something is. You have fixity checks, you'd have checksums for all the files. Those are like the basic bit level types of digital preservation. And you have to have redundancy. You have to have files that are copied in different locations, and on different storage media. So those are just basic steps one can do without needing expensive software or, having to expend a lot of money. It's mainly people. It's like I always say, digital preservation is people. You just have to figure out what can you do at a minimal level to keep your data alive, even if you don't necessarily have the wherewithal to know what is this format, what are the obsolescence factors. Just do basic data management of the files, to know what it is, call it something unique, have it backed up, have checksums. That's the least that one can do.
Great. Thank you so much. Um, when considering the long-term value of digital assets, how do you approach balancing cost effectiveness with ensuring their authenticity and integrity?
Um, well, that again gets into a couple of things: authenticity and integrity. The integrity is the checksum. You want to know that the bits, integral. Authenticity, that gets to be something very interesting, as I was alluding to in the SHA 512 conversation. Because usually people would say, all right, it's authentic file. We know that this file hasn't been changed because of that checksum. But now with AI and with quantum computing and fast processing, it is going to be a lot easier for bad actors to spoof checksums. They can go in, they can change a file, and then they can just spoof the checksum. And people will think, well, okay, it's fine, it's authentic, in the sense that in digital preservation, authenticity means like this file hasn't been changed, and it's going to get to be a little bit harder to do that, in the I didn't think it would happen, 10 years ago. I didn't think that would happen in my lifetime, but I'm thinking, oh, that can happen definitely within 5 years at this point. So things just go so quickly, change so quickly.
Definitely. Thank you. In the digital preservation field, collaboration plays a key role. And how does Digital Bedrock leverage partnerships or industry standards to enhance its services?
Yeah. Well, as I mentioned, it's like there is a global community of people concerned about digital preservation, but it has to expand. And so collaboration for me personally, for Digital Bedrock as a company, is because we work with in so many different communities, in different verticals, as some people would say. So we can work in the academic space where there's a lot of work happening in digital preservation. There is not so much thought happening in digital preservation in more corporate environments, but on the other hand, the corporate environments are concerned about security and high level security. And so the nice thing is because we have our feet, it's like, okay, I have 2 feet, but let's pretend I have more feet than that. And so you have to have your feet in all these different communities in order to hear, okay, they're doing great work thinking about security. They're doing fabulous work to speed up processing, like Quobyte, for example, here about being able to speed up things that we do. There's other companies doing, or another organizations doing fabulous work in thinking about how can we really monitor all these obsolescent factors over time. So you have to be able to be open to and not just be too siloed in how you're thinking. You have to be open and work in a lot of different communities and environments. And that's where collaboration of exchanging ideas, exchanging thoughts, on the best path forward.
Thank you. Looking ahead, what emerging technologies, since you mentioned AI, what trends do you see impacting the future of digital preservation?
Mhm. Well, okay, so I mentioned AI in a bad sense that it can be used to, corrupt data, but how some people in the digital preservation community are thinking about AI. So I mentioned appraisal. So again, you don't need to save everything because that's wasting storage, is wasting space. It can destroy the environment just keeping to collect all this data. So is it possible to use AI to help with appraisal decisions? For example, like, okay, go, have a tool to go through and say, all right, go through these folders. And so, but then that means a human being has to set those policies. You can't just say AI, just go figure out what we're going to do. You have to say,
Right.
I want to know that, all right, if I'm on a film is just wrapped, and it's all shot digitally. And we just produced a couple petabytes of data, just to shoot on the set. What do we need to keep, going forward? And then you can have AI go through if everything again is organized well, at least in like structures or by file names or some other kind of way to know this data is where, okay, put it here. These are our dailies. This is the raw footage. Maybe don't need to keep it into the future, but these are our masters that we do want to keep into the future in order to do restoration work or re-release the content, for example. So AI tools can go through to help identify then what should be saved for the future and what maybe not, or at least put something into a different tier. Okay, yeah, you have a couple petabytes of data you shot on the set. Put some of it off on LTO tape, for like 5 years and then decide, okay, we haven't touched it. We don't need to keep that, but we are going to be keeping our masters. So AI can be used to help make those appraisal decisions.
Thank you. I think we have time for at least two questions, and we have three. So let's try to get all of them in the time we have. My organization has neglected digital preservation in the past, but now we want to take steps to safeguard our digital legacy. How can I get started?
Oh, how can
Too
you get
long?
started? Yeah. I mean, I teach a whole class on this. How can you get started? Contact me. I mean, even,
Well, there you go.
I mean, yeah, I mean, even if people don't use Digital Bedrock, I mean, we're all part of humanity, and it's like, help people to learn how to get going and doing their own digital preservation if that's what they want to do.
Great. Uh, Somebody asked, is Digital Bedrock going to implement AI assessment into its processes?
At this point, no. Not to say that we won't in the future, but again, most of the work that we do, I mean, once all that analysis and the appraisal work and we get the data off the old storage and we really work with clients to help them to decide, do you want to preserve this? Oh, you have a bunch of duplicate files. Do you want to do everything? That's the bulk of the work that we do. Once the files are selected for preservation, at that point, then it goes through our system and is pretty seamless as it goes through. It's all of that initial appraisal work. So that's the part where I could see maybe AI being used. Again, if we can find tools to help us to help, basically is to help our clients, to choose. So it's that whole appraisal part, or maybe, yeah, that would be it. Because our system already pulls out all that metadata. We don't need AI to do that. So we're okay.